Hello and welcome to your Unit 3 review. I know this is technically our second unit test, but in the big scheme of things, this is technically Unit 3. So we're looking at the parallel lines and perpendicular lines throughout this unit, and we'll go side by side like we have in the past. And this is intended for you to be able to get 100% on this homework quiz, as well as allow you to be feeling prepared for our unit test, which we'll be taking this week on Wednesday. What is that? September the 25th. So please be prepared for that. Get ready, and we'll be in good shape. All right, first piece, just some vocabulary stuff. Use this image for questions 1 through 3. You're going to name a plane that is parallel to WXT. This, for the most part, is just kind of a, if it looks parallel, it is parallel kind of a thing. Like, there's not markings on it, but we're going to assume that if it looks parallel, then we're in good shape. So where's my plane I'm identifying? This is our WXT. WXT is this front face here. So I'm looking for the one that's parallel to that, which is probably that back face, V, U, Y, and Z. So now I'm going to look for 3 of those 4 letters and see what I can find. So V, U, Y seems to be where I'm at with that. So V, U, Y would be our correct answer there. All right, looking at number 2, identify 2 segments that are parallel to segments VU. So again, we're looking here, looking for VU, 2 of them that are parallel. So VU, again, is that back. So my other options that would be parallel would be ST or ZY or WX. So I'm going to go find those. And I've got my ZY and ST. Yep, ZY and ST, those are my 2. Let's double check that. But I'm fairly positive that's going to be our 2. Yep. Correct. There we go. Name 2 segments parallel to SW. So now we're looking for SW. SW is the kind of vertical piece here. Our other options would be VZ, UY, or TX. VZ, UY, TX. UY, TX. There we go. So those are our 2 options, TX and UY. Those are 2 parallels. All right, moving on. Hopefully that vocab makes sense for you and we're in good shape. So using this image for questions 4 through 8, name each angle pair as corresponding alternate interior, alternate exterior, consecutive interior, or no relationship. Identify what the transversal is that connects each of these pairs. So now we're going to be given some angle pair. You got to name the relationship and then identify the transversal that connects them. So 4 and 10 here. We're looking at 4 and 10. So as we look at these pieces 4 and 10, we would call those consecutive interior. And the piece that's tying them together is this transversal there, which is K. So as we go through here, we're going to call them consecutive interior. And we will identify the transversal, which is line K. All right, on to the next. We're looking at 8 and 11, same approach. So 8 and 11, where is that at? There's 8. 11 is over here. So 8 and 11. We've got as alternate exterior angles. They're on the alternate side of this transversal here, which is transversal M. So M is our transversal and alternate sides of it, and on the exterior of these other 2 lines that the transversal is cutting through. So those are alternate exteriors. Let's go to the next. 1 and 7. 1 and 7, where are we at? 7 is here. 1 is over here. Now those kind of look like they'd be related, right? But this is where I've got that line and this line that does not connect. And so there's actually, and for the other angle, I got that line and that line. And there's not actually a direct relationship. There's no transversal that connects those pieces together. So actually, this one would be our no relationship. So no relation. And that's for, what was that, 6? So for 6, we've got no relationship here. And then because there's not a transversal that cuts through it, again, you would go no relationship on that as well. So then the angle pair 5 and 7. So now we're going to look at 5 and 7. This is getting kind of messy. Let's re-clean this up. So 5 and 7 are here and here. There's 5 and 7. Those are corresponding angles. And we can see right through here is our transversal that connects them, which is our line J. So line J, corresponding angles. And that should be, is that it? Nope, we got one more, I think. 2 and 13. Let's look at 2 and 13. 2 and 13. There's 13 right here. All right, so 2 and 13, they're on the alternate side of this transversal. So our transversal is L, and these are alternate, but they're on the inside of these lines, so they're alternate interior angles. And again, our line is L. That's our transversal there. Okay, hopefully that gets you through the vocabulary parts there, fairly quick and simple. Now let's use these to help us identify some of the angle measurements that we would need based on some of these angle relationships. All right, so here's our parallel lines, P and Q. So P is parallel. That's important to know because now we know that all of our alternate interior, alternate exteriors, and corresponding angles are congruent. And we don't know anything about R and S, but based on how they're drawn, we would assume them to not be parallel. And that would be a good assumption. If it's not told that it's parallel, it's probably not parallel, with the exception of that vocabulary piece at the beginning. All right, so we want to find measure of angle 7 is 131 degrees. Measurement of 7 is 131 degrees. 16 is 88 degrees. And let's see, find the measure of everything else. All right, so I'm going to keep blue kind of be our default. We know that this is parallel to this. And let's go find everything else. So I'm going to find vertical angles. There's 131. Okay, that's angle 1, right? I've got parallel lines, so I'm looking for a corresponding angle. That's right here. So this is 131, which is angle 3. Vertical angle to that, or alternate exterior, would get me a 131 over here as well, which is our angle 5. And that's our 4-pack there. I've got the 88, so a vertical angle. There's another 88. That's our angle 10. Corresponding angle would get me up here to angle 12 is going to be another 88. Vertical on that is 88 over here. That's our 14. 88. Okay, so that's our 4-pack. How do I find the other ones? Well, this is just the linear pair stuff. So if I just go ahead and look at something like this, I know that these two angles will add up to 180 degrees. So then I know 131 plus, let's just use measure of angle 2 here, is going to equal 180 degrees. So I'll subtract the 131 from both sides. We'll see that the measure of angle 2 is 49 degrees. So we'll throw 49 in there. That's our angle 2. Our vertical then is 49. That's our angle 8. And then our corresponding is 49, which is angle 6. Vertical on that is 49, which is angle 4. Other side, this is the same type of thing, right? So we're looking, this will be the measure of angle 9 is what I've circled, plus that 88 will equal our 180. Subtract the 88 on both sides. Our measure of angle 9 is equal to 92. And so we'll know this is 92, which is our angle 9. Corresponding angle 92, which is 11. And the vertical to that is angle 13. And our vertical over here is 92 as well for angle 15. And now you've got all those angles put together. And this one's fairly simple. There's not a lot of crisscrossing lines that cut through the middle and break us apart. So realistically, you've just got the two givens and then all of their congruent pieces and the linear pairs off of that. So hopefully that makes sense. That's all of question 9. And then just go input all your answers into the answer key there for angles 1 through 15. All right, same approach here for number 10. Slightly different image though. We've got A and B, which are parallel. And then we've got that and that. D and C. All right, our information that's given this time, measure of angle 2 is 63, and measure of angle 9 is 105. Find all the other measurements. All right, so again, I'm going to start with just the congruent stuff. So vertical angle here is 63. That's equal to our angle 5. That might be it for that. Let's see, over here I got 105, which is our angle 7. And looks like that's it for that one too, because my corresponding angle is realistically this combo. So I'm going to use that actually here on this next piece. So I'm going to say that this measure of angle 1, which is here, right? This is our angle 1, plus that 63 is going to equal my 105. That's based on this being a corresponding angle. And so if I subtract the 63 from both sides, we'll see that the measure of angle 1 is equal to 42 degrees. So there's 42. Now I have a vertical angle, so that's also 42. That's for angle 4. And now let's use our linear pair like we've done in the past. So I know that the measurement of angle 10 is what that one is, plus our 105 equal to 180. So measure of angle 10 must be equal to 75. Those are 75 degrees. That's our angle 10. Our vertical here is 75, which is angle 8. The corresponding, this is 75, which is angle 6. Vertical of that is 75, which is angle 3. And we've covered all of that. The only stuff we're really missing is over here now. So let's see what we've got. Actually, here's a transversal D. Those are alternate interiors, so this is actually 42 degrees as well, which is angle 11. Vertical here then, so this is 42, which is angle 13. So that kind of gets the ball started over here for us. And then based off that, we can linear pair it again. So our measurement of angle 14 is equal, or plus, measurement angle 14 plus that 42 degrees there is going to equal our 180. So pull that out and we get what, 138 is the measurement of angle 14. So 138 is angle 14, and the vertical on that is also 138, which is angle 12. Now, if I was like, I don't know if that's true, right? We can always double check this. So I know that this piece here is also corresponding to this. So if all was matching up, 63 plus 75 should be 138. And sure enough, 60 and 70 is 130. 3 and 5 is 8. So 138 matches up. Everything's looking good. Again, take all those numerical values, throw them into the answer key here, and you'll have all of those. So there'll probably be just one of these types of questions. I would guess, I haven't built it yet, but my guess is it'll look more like the one we just did, where it's got a little extra critical thinking to it. The first one's a little more basic. All right, so find the values of x and y here. This is going to involve a couple multi-step things here. So this is where algebra kind of jumps back in on us. But we still got to know our relationship. So we know that this and this are corresponding angles. The question is find x and y if these are parallel. So if these are parallel to each other, L and M, then we know that the corresponding angles are congruent. So we can say that 5x plus 14 is equal to 7x minus 30. We'll subtract 5x from both sides. We'll add 30 to both sides. We'll divide by 2. And we'll see that x is equal to 22. Well, now, in order to get from this point to finding what our y value is, we need to go ahead and find out what this angle measurement is, because we know that this creates our linear pair. So if I can figure out what that is, now we can really figure it. Well, I guess realistically, if you wanted to, you could say that that 3y plus 11 plus the 7x minus 30 is equal to 180. But if we'd done that right away, I'm like, well, I don't know what x is. So x is 22. So we've got 3y plus 11 plus 7x, which is 22, minus 30 is equal to our 180. And so 7 times 22 is 154. Minus 30 plus 11, 3y. And so we'll get 3y minus 30 is 124. I'm not going to do this all in my head. So this is 124, which means this is 135. So subtract that 135 from both sides. 3y will be equal to 45 divided by 3, so y is equal to 15, and we're in good shape. So, again, that's just one way you can do it. And the other way I was kind of starting to describe is if I had plugged it in, we get the 154 minus the 30, so we know that this angle measurement is 124. Like that's the actual measurement there. So then this angle measurement over here must be its complement, which would be, what, 56. And so you could set up the equation that 3y plus 11 is equal to 56. Same approach, it's still going to work out. This equals 45, y equals 15. So again, just a couple different ways that you can look at this. Pick whatever your favorite preference is and go from there. There'll be a couple questions like this. If you're in my third period, I probably won't have you find the y value. But for periods 1, 2, 4, and 6, I would definitely plan on being able to find both x and y here. All right. So I know that this angle and this angle are alternate exteriors. And so I know alternate exteriors, if these lines are parallel, are going to be congruent again. So I can say that 10x minus 17 is equal to 8x plus 1. So 2x is equal to 18, x is equal to 9. Hopefully that part is not that difficult. You're like, oh yeah, that's making more sense to me. I would go ahead and find out what this angle is. So I'm going to say this is 8x plus 1. So this is 72 plus 1, which is 73. So I now know my complement over here is 107 on this side. That was from 180 minus the 73. It told me that my supplementary angle over here is the 107. And so I now know that 6y plus 29 is equal to 107. Let's subtract 29 from both sides, which is what, 78? Divide by 6, which is 13. Y equals 13, and we're in good shape. Last one of these, I believe. Let's see, this time our two expressions with x are on the inside here. And so we know that those are consecutive interior angles, and we know that those are supplementary. Supplementary means add up to 180. Good. Okay. So I'm going to take those two angles in. So my 23x minus 16 plus my 8x minus 21, and I'm going to set it equal to 180 because I know those two angles are supplementary. Combine by like terms, what do we get? 31 x's here minus 37 equals 180. If I add the 37 to both sides, we'll get a 31x is equal to 217. Divide by 31, x will equal 7. Cool. All right. Now I'm going to go and look here because y is this vertical angle over here. I'm going to say, okay, if I can get this angle measurement, then I know it's equal to this one because they're vertical angles. So I'm going to go do my 23x minus 16. So we get 23 times 7. Let's see, 23 times 7 is what, 140 plus 21, so 161 minus that 16. 151, 145. So this is equal to 145, which means this is equal to 145 degrees. That allows us to build the equation 145 is equal to our 7y minus 23. Add the 23, so we get 168 equals 7y divided by 7. 20 would be 140. Got 28 left over, so it would be 24 is equal to our y value. Or use your calculator. Should get you in the same spot. All right, I think we're feeling good there. Cool. So you got to know your angle relationship. That helps you set up the equation, and then we're just going to do some algebra with it. Using this image for 14 through 18, given the following information, determine which lines, if any, are parallel, and state the converse that justifies your answer. So again, we're looking at angle relationships, a lot of this. So which lines, if any, are parallel? If 8 is congruent to 20, so I gotta go find 8. There's 8. Let's see here. 1, 2, 3. This is my x, y, z, and m. So 8 is here, and 20 is here. And so if I kind of ignore the y value and I just think about these two lines that are being cut by the transversal n, then I can start to see that, hey, look, those look like alternate interior angles between x and z. And I know that if these are congruent, then the lines are parallel. So I would go and check mark my line X and my line Z, and those would be parallel. And then my justification for this is it's the converse to the alternate interior angles. And I know that because if the lines are parallel, then the angles are congruent. So the converse statement is if the angles are congruent, then the lines are parallel. All right, so that's kind of what we're doing with all these. 1 and 9, let's go look at that. So 1 and 9, 1 and 9. So there's my transversal, there's my two potentially parallel. Those look like corresponding angles. So my corresponding angles, if they're congruent, then the lines are parallel. So now I've got X is parallel to Y. This is for 14. This was for 13. And so corresponding, or the converse to the corresponding, is going to tell me that since those are congruent, then X is parallel to Y. Okay. Next, wait, was that 14? No, I lied. That was 15. Correction. I was off by 1. This was 15. This was 14. Okay. On to 16 then. Let's look at 16. 16 is 3 and 10 are supplementary. So 3 is here, 10 is there. 3 and 10. And if those are supplementary, those look like consecutive interior angles. And we know that if our consecutive interior angles are supplementary, then those lines must be parallel. So again, X and Y are parallel, but this time it's the converse of our consecutive interior angles. I think there's one more, 17. Maybe there's two more. Are there two more? There's two more. 17. Let's see if this becomes too cluttered or not. That's 17 we'll do here in blue. What was I looking at? 11 and 16. So 11 is here. 16 is here. And I know that 11 and 16 are congruent. Does that tell me anything about those lines? No. In fact, if anything, if those were congruent with each other, they'd have to be like alternate interiors, but because these are consecutive interior angles, we would expect those to be, well, it's an interesting thing to kind of point. No. Yep, we don't know anything about this. We would expect those to be supplementary to tell us that M and N are parallel, but we don't actually know that because they're congruent. So this might just be creating some form of a trapezoid, which, I mean, if you look at the picture, right, this is a trapezoid. So it's got one pair of parallel lines, the other ones are definitely not. But your base angles and your top angles are congruent. That's one of those things we'll look at later in the year. So forecasting, there you go. So this would be no parallel lines, or what do I say, no relationship. No parallel. No lines are parallel. Yep, perfect. And again, no lines are parallel is what you would check for your justification as well. 18A, which lines? We got 14 and 23. 14 and 23, last one. 14 is over here. 23 is over here. Those, here's my transversal. So here's my potentially parallel ones. If I have alternate exteriors, so 18 alternate exterior, if they are congruent, then the lines must be parallel by the converse statement of alternate exteriors. So, all right. Hopefully, again, that's just working through some vocab. Now we're doing the converse, though. So it's like, hey, something about the angle measurements. Can you tell me if the lines are parallel or not? So keeping that same theme here, now we're going to go find a value of x that makes these lines parallel. So basically we're proving the converse statements here, and we're going to justify our answers with those converses as well. So if I've got these, the question, oh, and I didn't label this, I apologize, I created this. Maybe I'll update it here if I can remember before I post this to you. But if this is J and this is K, in order for these to be parallel lines, what do we know about consecutive interior angles? We've talked about this several times now, so hopefully you're like, oh yeah, consecutive interior angles must be supplementary. So I'm going to take that 2x minus 8, I'm going to add it to my 9x minus 10. Supplementary means that those two angles will add up to 180, so this is 11x minus 18 equals 180. Add the 18, so 11x is equal to 198. And divide by 11, we'll get x equals 18. So x equals 18. Our justification for this is the converse to our consecutive interiors. So x here is going to equal 18. And we're the converse to consecutive interior angles. Okay. All right, looking at 21 now. What is the slope of a line parallel to this line y equals 2/3 x minus 5? This is, and I think you guys have seen this in Algebra 1, so I'm hoping this is review, but it's in the form y equals mx plus b. M is slope. So the slope of this line is 2/3. We know that slopes of anything that is parallel slopes are the same. Okay, so I'm expecting the slope of a line that's parallel to this line must have the same slope. So my parallel slope must also equal 2/3. I'm looking in here, boom, there's my 2/3, and I've got my slope. What's the slope of a perpendicular line? So a perpendicular slope, we know is, because these are going to meet at 90-degree angles, right? Whereas our parallel lines were, they never touch. So they got the same slope, so they never touch. Perpendiculars intersect each other at a very specific way. If I've got slope of something to be some a over b, the perpendicular slope of it, so my second one, is going to be an opposite reciprocal. So I'm going to go from positive to negative, or from negative to positive, and I'm going to flip my fraction. So in this case, from a to b to a, or b over a to a over b. So what I'm looking for now, because I'm using the same equation, we don't have to think too hard about this, still the same equation. We know the original slope is 2/3, so then my perpendicular slope to this must be opposite. So it was positive, it's going to become negative. Was 2/3, reciprocal is going to become 3/2, and that's what I'm looking for my perpendicular slope versus my parallel slope. All right, so we're going to scroll through this and find our opposite. So B is opposite but not a reciprocal. C is opposite and a reciprocal, so there's our answer. Where D is just a reciprocal, not opposite. Cool. All right, 23. Going to go ahead and determine if these lines are parallel, perpendicular, or neither. So using what we just talked about, right? I got to find the slopes first, but once I have the slopes, let's compare them. So slope of AB is our first question. Slope formula, right? It's your change in y over the change of x. So we can look at, some of you got taught your rise over run, right? Mathematically, what this is talking about, though, is I'm going to take some coordinate point, call it my second coordinate. I'm going to subtract the first one to find the distance between them. I'm going to do the same thing with my x values. The important piece is that you stack your coordinate points over the top of each other and don't get them mixed up. So it doesn't necessarily matter which one I put first. For me, I'm going to do B as my second coordinate point. So this will be a 4 minus 5 over -8 minus a -11, which becomes a -1 over, this is like plus a positive, so that's a +3. So I know my slope of AB is equal to -1 over 3. Slope now for part B is to go find the slope of CD. So slope of CD, I've got my coordinate points here. -4 minus -7 over -1 minus 8. So this again becomes plus a positive. So -4 plus 7 is +3 over 1 minus 8 more is a -9. I can simplify that and it becomes a -1/3. So again, slope is -1/3. And if I compare these two, they're the same. And what did we just determine was parallel, perpendicular, or neither? If the slopes are the same, then these must be parallel. And this is part C. So there's part A, part B, and part C for number 23. For 24, same approach. 24, part A, I'm going to find the slope of AB. So we've got 15 minus 8 over 1 minus -3 equals 7 over 4. So slope equals, and if I'm typing this in, I guess I should show this. It's 7 and then it's the /4. So use the slash for division. That's what you would type into the computer. Part B, slope of CD equals -5 minus -9 over 3 minus 10 equals, it's like plus positive, so this becomes a +4 over a -7. So my slope here, -4/7. If I put the negative on the backside, it'll still register it. That's correct. But I would encourage you to put the negative on the top just for, I guess, kind of proper math etiquette, I guess. I don't know. But the answer key over here should recognize it if you put the negative on the 7. That's totally fine. Now, let's compare these two. I got 7 over 4, -4 over 7. That sure looks a lot like an opposite reciprocal to me. And what do we know about opposite reciprocal slopes? These must be perpendicular. Boom. So that's part C. Perpendicular. All right. 25. I think we got one more. 25. Slope of AB equals 4 minus -3 over 9 minus 9 equals 7 over 0. Oh my gosh, what happens when I divide by 0? The world blows up. No, we just call this undefined for the moment, right? And I'm going to encourage you use UND for your simplification of this. That way you don't have any spelling errors with undefined. It can be lowercase, it can be capital, it can all be capital. Just don't do like some weird zigzag of capital and lowercase because this thing's finicky as far as capital letters as well. So lowercase m for slope, UND, either all lowercase, all capitalized, or capital U only is fine as well. If you want to, you can spell it out undefined, and that will also work. Okay. Undefined slope divided by 0 is an undefined experience at the moment. What this looks like is a vertical line, in case you're curious what that looks like visually. Okay, so that was part A. Let's look at part B. Slope of CD equals 6 minus 10 over -2 minus -2. And we're going to notice we get a negative 4 over 0 again, which is also undefined. So both are undefined, which means they're the same slope, which means these must be parallel. So both lines are vertical. These are parallel. That's part C. Awesome. Horizontal lines are slope of 0. So if you had 0 over stuff, that would be slope of 0. 26, determine if the lines are parallel, perpendicular, or neither. So now all I got to do is go find the slopes, identify them. So I've got a 6x plus 10y. This is 26. Equals 20. Oops, equals 20. I'm going to solve for y, because if I can get it into the form y equals mx plus b, I'm in good shape because there's my slope, right? So I know that's my slope. That's a quick way to find it. So I'm going to subtract that 6x over. I'm going to divide by the 10. Oops. And if I simplify this, I get negative 3/5 x plus 2. Most important is that. Now I know the slope of that line. Second equation is 5x minus 3y equals 21. Same approach. Negative 3y equals negative 5x plus 21. We'll divide by 3, so or negative 3. So negative 5 over negative 3x plus 21 over negative 3. We get a positive 5/3 x minus 7. And there's my second slope. I want to compare those two. One's negative, one's positive. So there's my opposite. One is 3/5, one is 5/3. There's my reciprocal. So these are perpendicular. Cool. 27, similar approach. X minus 5y equals 30. I'm going to negative 5y equals negative x plus 30 divided by the negative 5. So we get a positive 1/5 x minus 6. Sorry, I shortcutted that a little bit. If you need to see the in-between steps, go back and look at the last problem. Same exact approach. So 10y equals 2x plus 90 divided by 10, 1/5 x plus 9. I'm going to compare my slopes. 1/5, 1/5. These are the same slopes, so they are parallel. Good. All right, we're getting down to it. 28. Let's see, what are we doing here? 28, write the equation in transformation form. So that's our y equals m times x minus h plus k. Okay, I'll give that to you, partly because it's the required formatting. I don't want to have to mess with a bunch of grading. So you won't have to memorize that. You just have to know how to use it. Of a line that passes through a point, negative 6, 1. This is my h comma k, and has a slope of 1/2. So the slope is 1/2. The coordinate point, negative 6, 1, is h comma k. And so I want to be able to plug that information into a formula. Y equals m x minus h plus k. And the only thing I gotta do is simplify inside there. So 1/2 x plus 6 plus 1. Again, the reason why this is a good formula or a good form for an equation is because it tells me I took something and I vertically stretched it by 1/2. I shifted it 6 units to the left and up 1 unit. You're going to use that a ton through Algebra 2 and pre-calc on how do we transform different equations all over. So second part to that, actually let me pull this back up. Second part of this is 28. That's part A. Part B now is put it into slope-intercept form. Don't do extra work here. It's part B for a reason. So use what you've already got, and you're just going to distribute this equation through. So start where you got to, And now get it into y equals mx plus b by distributing the 1/2, combining your like terms, and so y equals 1/2 x plus 4. So you can't just throw in some random number for your y-intercept. Just simplify this by multiplying through and combining your like terms. Alrighty, let's take a look at what's next. 29. What's an equation that runs through this and this? Okay, so now we're going through 2 points. So I have to find slope. Slope of this line is equal to 1 minus 6 over 3 minus negative 2. Hopefully you're getting really good at doing slope at this point. Negative 5 over 5, so this is a negative 1 for slope. Now you can pick either one of these coordinate points, and the answer key is designed that way as well. I'm just going to grab that very first coordinate point, the 3, 1. So I'm going to call this y equals negative 1 times x minus h plus k, and I'm done. All right. You could have also done the second coordinate point, so this would be y equals negative 1 times x minus h plus k. That's totally acceptable. And if you wanted to be an overachiever for whatever reason and throw it into y equals mx plus b, feel free, distribute that through and combine your like terms. Negative x minus 2 plus 6, so this is a negative x plus 4. This is also an acceptable answer too. Okay, so whichever format you like best, go for it. All right, I think these are our last two. Yes, all right, we're going to do a parallel one. We're going to do a perpendicular one. So kind of the same approach to start. You've got a linear equation, 5x plus 2y equals negative 8. We want to be parallel. That's our key. So parallel tells us the slope is the same. So what's my slope of this line? I'm going to go ahead and subtract the 5x, divide by 2. And so there's my slope. And now I have a coordinate point over here, 8, negative 9. And that's just an h comma k. So I got y equals negative 5 halves x minus h plus k, and we are done. How are you typing this into the computer? Let's just kind of double check that. Y equals negative 5 slash 2 open parenthesis x minus 8 close parenthesis minus 9, no spaces. Okay, keep in mind the whole time through here we got no spaces when you're typing these in to the answer key on the Google form. Okay, last question. Let's finish strong. We've got a linear equation that is perpendicular this time. So perpendicular tells me that my slope is opposite reciprocal, right? So if it was some a over b, it's going to become negative b over a. That's what we're looking for. So looking at this equation now, y equals negative 4x minus 6. The original slope is negative 4, which, keep in mind, slope of the negative 4 implies it's over 1. So then my perpendicular slope to this would be a positive 1 over 4. Okay, so now I have slope. They've given us a coordinate point of 410. Our equation is, y equals 1/4. There's my perpendicular slope. X minus h plus k. And we're done. Try not to overthink those or overcomplicate them, but I will accept it in slope-intercept form if that's your preferred method. You'll have to do some multiplication and keep working. All right, I hope this sets you up for success. Good luck on your test on Wednesday. I will be at school for Pride on Wednesday morning at 7:30, so if you want to come in for extra help, please do that. I also have second lunch and 5th period prep if you need to come see me. If you want to visit after school, Tuesday after school will be your best day to do that. I got a volleyball game on Tuesday, so I got some time after school. All right, good luck. Hopefully you get 100%. Let me know if you got other questions. You got this.